Hello students, the fifth module, the third chapter is support vector machines. So introduction, what is support vector machine? So the support vector machine is a mathematically rigorous and machine learning technique to build the linear binary classifiers. So here I'm using the word linear binary classifier. So linear binary classifier, nothing but it will be creates some hyperplanes in the high dimensional spaces. So high dimensional space nothing but it will be take the n dimensional spaces, nothing but the n number of features that is distinctly classifies the some separate data points. Then it will be accurately it will be slice the data sets into the two segments according to their desired objective. So and this algorithm will be developing to classifier to mathematically challenging through like the SVM is a popular since the state of the art and many practical problems. So as well as it will be identifying some spam emails and other text mining applications. And other way we can also define the support vector machine is a supervised machine learning algorithm that can be employed for the both classification and regression purpose. Nothing but here the classification and regression purpose, nothing but the more commonly used classified problems, classification problems and such problems, the focus on this point, nothing but which type of points it will be focusing on. So the main idea is behind nothing but it will be finding the hyperplanes. So this hyperplane is nothing but it will be dividing the data sets into the two classes. Two classes nothing but it will be in the below figure we are using the two classes and the two types of the data sets. So these two types of the data sets, so we can also call as a support vectors. What is mean by support vectors? So support vectors is nothing but the data points. So I am using the two sets of the data points here. The first set of the data point is a green color and another set of the data point is the blue color. So these two data points that are closest to the hyperplane, that is called as support vectors. So here which one is a hyperplane? I am telling the hyperplane. Okay. So which one is hyperplane here? So the middle one line is there. The blue as well as the green, the data points will be there. The middle one line is there, the closest to that hyperplane. That is called as hyperplane. So the that closest to the both data points, that is called as a support vectors. The separating lines will be defined the help of the data points to distinguish the data two sets of the data points. And next one is what is hyperplane. So hyperplane is nothing but this is a decision plane or the space with the divided between the set of the objects having the different classes. So here you can easily classify the two classes of the two data points in that hyperplanes. And for example, just you can classify the task, okay, with the only the two features, like you can take this above image. So I'm using the two sets of the data point, the two sets of the data points with help of the it will be divided the hyperplanes, and you easy to categorize in the both set of the data points, and you can find out the which data point is more accurate and which data point is not accurate, like that you can easily categorize. So you can think that hyperplane as a line, it will be linearly separated and classified as a set of the data, and this hyperplanes will be lines with decided class that assign on it. Nothing but suppose if your hyperplane of the data points will be lies more confidence, so we are that having the correct classified that data points far away from the hyperplane. It is possible still the current size of the both data points, it should be a left data point or the left right data points of that hyperplanes. And next one is the margins. So margin is nothing but it may define the gap between the two lines of the closest data points between the different classes. So just you can see the below diagram. So I'm using the two data points, the one is a green color and another is the the blue color. Okay, and center one line is the hyperplane, and there is a gap will be there the between that hyperplane, the green data sets, and the green and blue data points. So in middle some the gaps will be there. That gaps is called as margins. So it can be calculated with help of the perpendicular distance between the lines of the support vectors. Here some large margins is considered as a good margins. Suppose if you are getting the large space gap between the data point and that hyperplane, that is called as a good margin. Suppose if you are getting the small margin, that is called as the bad margins. Okay, as well as the in we are also called as that margins mmh. Okay, we are also called as a mmh in the sorry. So we can also call it as a mmh. mmh nothing but the maximum margin hyperplanes. So main goal of that mmh, SPM will be divided into some data sets into the two classes. So first class it will be generated the hyperplane, nothing but it will be iteratively segregated the classes in the best way, and second way that hyperplane will be separated the classes correctly. The first one is the how do we find right hyperplane, we can also call like that. So how do we best segregate the two classes within the data? So this is nothing but the distance between the hyperplane and nearest data points, either sets of the both margins. So then we will get the right hyperplanes. So here the main goal of that hyperplane will be the greatest possible margin between the hyperplane. Why I am using the greatest possible margin? Because suppose if you are getting the more margin, so that is considered as a good margin. Suppose if you are getting the small margin, that is called as a bad margin. So the main goal of the right hyperplane here, so you can get the as possible as the greatest margins, nothing but the large margins, that hyperplanes. And after getting the hyperplanes of the large margins and any points within that training sets, it will be giving the greater chance of the new data begin classified correctly. If you are getting the large space in the both data sets in the blue as well as the green, in center of hyperplane will be there. So if I getting large, so you can easily identify the two sets of the nothing but the training set or the data sets, you can correctly classify there. And next one is the but what happen when were no clear hyperplanes? Nothing but here it can uh, very tricky. The data is really ever clean. Our simple example of the data sets will be looks like jumble balls. Okay, jumble balls, it will be mix up. So we cannot easily find out the data sets because the data sets are the completely merged here, I mean combined here. So here we are using linearly non-separatable data sets here. So suppose you can take just you can imagine here the two sets of the colors balls will be there here. One is a blue as well as one is a green. That all balls will be sitting on one sheet. Suppose if a sheet that sheet will be shifted suddenly, okay, automatically that all balls will be launching in the air. While the balls are in the air, so suppose the user the sheet will be separated them, so automatically all the balls will be lifting, represented the mapping of data into the high dimensions. So after lifting the all the sheet, so automatically all balls will be fall down because uh, just I have kept the all balls in the air. So automatically the all balls will be uh, falling down. After falling that all balls, the data will be having some high dimensions. So high dimensions of that all the balls, then automatically the all the balls will be moved from the anywhere in the ground, so that moving the all the balls, so here not it will be segregated the blue as well as the green color, so that is known as the some kerneling. So we will study the how exactly the kerning will be works in the next slide. Next one is the SVM model. The first one is the SVM working, the support vector machine, how exactly it will be works. In the SVM model, the basically it will be representation of the different classes of hyperplane. So already explained what is hyperplane. So the hyperplane in having the multi-dimensional spaces, nothing but if I'm using the word n-dimensional spaces. In this hyperplane will be generated iteratively manner. After iteratively it will be automatically will be segregated the all the data sets with help of the different sets of the classes. And the SVM, the support vector machines, that how the error can be optimized. So error can be optimized means the main goal of the SVM, it will be divided the set of the classes. Okay, after dividing the set of the classes, the maximum it will be find the maximum margin hyperplane, nothing but it will be MMH. So what is the main goal of MMH? So MMH's main goal is and the support vector machines divide the data sets into the two classes. In the first class, the support vector machine will be generates hyperplanes iteratively. After generating the iteratively, it will be segregated the classes the best ways. And second one, it will be choose the hyperplane separated the classes correctly. First, it will be segregated all the classes. After segregated the classes, it will be collect the or separate the correct classes. So this is a working of SVM. And in this below diagram, so here using the data points for the classifications. Okay, in the SVM classifies the high dimensional space, define and decision boundaries between the two classes. Nothing but here the support vectors data points will be defined in the terms like gutters or the boundary conditions, either hyperplanes for each two classes. Nothing but it is easy to understand the SVM. Suppose there is a labels. Suppose there is a labels here. Labels that there are two classes. The here here one more label is there. Here I am using one more data set, and this is a X data set. This is a blue color and this one is a red color. The two classes, the main goal of to find the classified between the two types. Okay, in the SVM takes some vectors, nothing but it will take the widest street approach and demonstrate that the two classes nothing but the two data sets, the hyperplanes that are having the widest margin. So widest margin means nothing but from here I'm using the one data set, and here we're using the one more data sets, and here the distance between the from this data set to this data sets. So we will get the widest margin. Suppose if I are getting the widest margin, so automatically that is a good margin. Okay, the largest distance between the training, that the training data points will be either class or some having some optimal planes. And next one is in the same, the support vector machine classify. This one is, so here nothing but from this line, dotted line to this dotted line, this is the widest margins, and center line is the that is called as the optimal hyperplanes. Here he is using the word as a maximum margins, and this dots and these dots are the nothing but the support vectors, and this dotted line and this dotted line, that is called as a girders. Okay, in after the hard line, this is nothing but the optimal, the nothing but the center line, the optimal hyperplanes. So the dotted lines will be the here some gutters of the two classes. The gap between the gutters as well as the maximum or the widest margin. So maximum or widest margin, the classifies the nothing but the hyperplane. Those points will be fall on the both sides of the gutters, nothing but the dotted lines, and these points will be called as a support vectors, nothing but here it will be represented in the bold shapes blue color as well as the red colors, and these points will be called as the support vectors. The rest of the data points are classes are irrelatively defined. Their classifier defining classifier nothing but the and here it will be not showing, it will not unfilling here, only the some parts it will be filling, and remaining parts will be just using the some data such as the classifiers. So actually suppose the training data sets having the endpoints, so it is represented in the this like x1 y1. I'm using the x-axis as well as the y-axis. So x1 y1 till you can take the xi to yi. So here xi is represented the p values of the vector points I, and yi is nothing but the binary classes values. So the binary classes values range is +1 to -1. These two classes can be represented as in the form of the 1 to -1. And next one is the here just here using some equations related to the that support vector machine classifiers. The first you can assume the data is linearly separatable. So suppose in that case this the classifier hyperplanes will be defined the set of the options. So set of the option nothing but this is a subset of the training data, nothing but that data sets, the two colors of the data sets. So that will be satisfying the equation, it should be satisfied the first equation w dot x plus b equal to 0. Here the w is a normal vector plane, this equation should be satisfied, then only you will get the proper support vector machine classifier, otherwise you will not get the support vector machine classifier, because the all the data will be linearly separatable here. And next one is the hard margin here. Next one is the hard margin can be defined the following hyperplanes. Here I'm using the two equations. The first one is the w dot x plus b equal to 1 and w dot x plus b equal to -1. Okay, as well as well I'm using the width of the hard margin is the 2 divided by w. Okay, 2 divided by w here. So all the data points not in the hyperplanes, so they will be a safety in their own classes. So the y values will be either greater than 1 or less than 1. Greater than 1 means the for points the class is 1, less than -1 is the points class is -1. And this algorithm in SVM algorithm we are using the weighted vector w. Okay, why I'm using the weighted vector w, the main feature of that w, because it will be having the widest margin between the two categories, nothing but it will be using the greatest margin between the two data sets. With help of that hyperplane you will get the good margin in SVMs. Then in how to compute the SVM using this equation with having the hill climbing process problem. So in the here in the hill climbing process problem we are using the convex space. So by working with points in the nearest classifying boundary only, it will be reduce the some number of the distances, sorry not distances, instances to work with, reduce the memory requirement as well as the computations as possible as it will be reduced. Then you will using the one of the kernel method. And next one is the kernel method. So in SVM kernels, so I'm using in this algorithm it will implements the some practice of using the kernels. So kernel is nothing but it will be transformation of the input data space into the some required forms, nothing but the SVM in this techniques it will be used as a kernel tricks. So the kernel will be takes some low dimensions. Normally in SVM you are using the high dimension or a multi-dimensional or the n dimensions of the input spaces, but here we are using the low dimensional input spaces and then transform into the higher dimension spaces. In normally in SVM directly we are using the high dimensions, but here it will be takes the low dimension spaces, it will be transform into the high dimension spaces. In the other words you can say like it will be convert the non-separatable problem with help of the non-separatable problem to the separatable problem by adding more than the dimensions, one dimensions. Nothing but it will be using the non-linear separation problem, because the kernel is tricky help to build the more accurate classifiers. Because normally in SVMs we are using the directly we will taking the high dimensions. So in the high dimensions with help of the MMH, so it will divide into two classes in the segregated separated the two classes, and after the classes will be identify the best class. But here it will be starts from the low dimensions, it will be later it will be converted into the form of the high dimension, nothing but non-separatable problem to separatable problems with adding the uh, all type of the dimensions, low as well as the high dimensions. So the kernels having the some methods. The first one is the linear method. So linear method nothing but it will be using the normal dot product, nothing but it will be using in the given observation the product between the two vectors, and the sum will be multiplication of the pair of the values. For example, so you can take the x k into bracket of x xi, then you will get the sum of the x into xi. This is the linear. And next one is the polynomial kernel. Polynomial nothing but will be generated the uh, sorry, not generated, it is a generalized linear kernel. So it will be distinguished uh, curve, curved or non-linear input spaces. For example, so normally we are getting the k of x xi, we will get the sum of the x xi in the linear kernel. In polynomial kernel we will get the uh, x xi, k of x xi equal to 1 plus sum of x xi square root uh, x xi raised to d. You can take the n number of the d means it is nothing but a degree of polynomial. So you can take d equal to 1 or d equal to anything. It is similar to the linear transformation. The degree need to manually you can specify with help of the that linear algorithm. And next one is the SVM two major constraints, advantages of SVM, disadvantages, and last one is the some summaries. So first one is the major constraints. The first constraint is it will be works only the real numbers, works with only real numbers, nothing but so all the data points in all dimension must be defined in the numerical values. In nothing but in the kernel method we are using the both high dimensional and low dimensionals, and SVMs only we are using the high dimensional. So the major constraints here, you can take the any dimension of the data points, it should be in numerical values. And second constraint, it will be works only the binary classification problem, means one can make the series of the cascades. So SVM will be get around and around this constraint, nothing but suppose if you're training if you're taking the insufficient and time consuming process in the SVMs, so data, when data is large, so it does not works well. So there is a much noise in that data. So in that case you can use the compute the some soft margins. After getting you in SPM will not provided some probability estimated classification. That's why, so you can your confidence level will be classify the instances of that SVMs. And next one is some advantages and disadvantages of the SVM. The first advantages, so it will be works really well, clear margins of separation with clear margins of separation, nothing but if you're getting large margins this is a good margins, if you're getting the small margins this is a bad margin. And it is a effective high dimensional spaces. Okay, in normally kernel we are using the both type of the dimensions, high as well as low, as well as in the SVM in high. In the both cases it will be works effective, and it is a effective cases when the number of the dimensions is greater than number of the samples. and it will be used a subset of the training points in the decision function. Nothing but it will be using the support vectors. Support vectors is nothing but the data set separated with help of the hyperplanes, that is called as the support vectors. So it is also having the more memory efficient here. These all are the advantages of the SVMs, and some disadvantages also there in the SVMs. So it does not perform the well when the large data sets, because it will be required the training time is higher. Suppose if I taking the more number of the data sets, so it will takes the more number of the time, because in the SVMs only we are using the high dimensional spaces or the multi-dimensional spaces. Only I'm using the SVMs, not kernel method. So this is one of the disadvantages. And the second disadvantage, it does not perform very well, because when data sets have n number of the noises, so automatically the target class is overlaps the both data sets in left side as well as the right sides. And the last one disadvantage is it does not directly provide the probability estimated. Okay, it will not give any probability estimated classifications. So automatically we cannot calculate the expensive to like validations of the your computed the soft margins. So automatically the confidence level will be classifying the instances of that um, with help of the SVMs. So automatically it will be give the inefficient, and it will be take the time consuming processes. These all are the disadvantages of the SVMs. Finally, I'm using the word summary. Summary means, so it will covers the all things of the SVMs. So here the already we have studied the support vector machines is the one of the machine learning technique. It will be classifying the high dimensional data into the classes, and it will created the hyperplanes with large amount of the separation between the two classes. And these classifiers will be made linear by transforming original features to the input data into the new features. And this SVM using the kernel method, already explained kernel methods. So it will be having some specific instances that close to the dimensions boundaries. And this SVMs would be used text mining, spam filtering, outliers detections, and image processing. In these all fields we will be using this support vector machines.